Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. Also, if the videos are helpful in your studies, please don't forget to subscribe. That's the only way to keep me going, inspired and refreshed. So this was solved by three moment equations. Let's verify the answers by the moment distribution method. So analyze the continuous beam shown by determining the entire moments at C, D, and E. EI is constant. So the loadings are basic, so you need to just familiar the formulas. So my technique in considering the overhang is to make it the last support so that uh, we can modify the stiffness of member BC and to simplify the tabulations. So I made it 18 kilonewtons acting at A, but this has no contribution to moment in BC. And the couple, which is 18 times 1.5, so 27 kilonewton meter. For BC, it is negative 27 expected, while for BA, it is clockwise, so positive 27 kilonewton meter. So computing for fixed moment BC, it is for couple, it is positive negative 60 because this is counterclockwise. B, which is 5 over L square, quantity 2 times L minus 3B. So 2 times L minus 3B, where B is 3 plus 2 or 5, and A is 2. Then for the 40 kilonewton load, negative 40 times 5, 2 square over 7 square. 40 times 5, 2 square over 7 square. So this value is positive 6.122. This one is negative 16.227. So fixed moment in BC is negative 10.205 kilonewton meter. While fixed moment CB is negative 60 times 2 over 7 square. A is 2. Then 2L minus 3A. So 2 times 7 minus 3 times 2. Then positive plus 45 square 2 over 7 square. So take note that at C for the couple load, for the concentrated or point load, it's positive. And for the couple load, we just use the formula directly and compute the result whether positive or negative. Positive means clockwise, negative means counterclockwise. So negative 19.592, this value, and this value is 40.816. Combining fixed moment CB is 21.224 kilonewton meter. So because B is now the end support and last support, and we just apply these loads, but the expected moment at B rather would be 27 negative 27. So this is the end support. So the internal moment there is 0. So we modify the stiffness of BC by multiplying 3/4. Again, that's my technique. So 3/4 of 1 over 7 is 3 over 28. So that's the end support. So that's why its stiffness is modified to by multiplying 3/4 of 1 over 7, so 3 over 28. This is 1 over 6. We expect moments at C and D as well as this. So this is 1 over 8 because we expect moments at D and E. So let's now tabulate. So the distribution factor for B, because it is the end support, roller support, is negative 1. For C, negative 3 over 28 over quantity 3 over 28 plus 1 over 6, so negative 9 over 23. So CD should be negative 14 over 23. For DC, negative 1 over 6 divided by 1 over 6 plus 1 over 8, so negative 4 over 7. So for DE, negative 3 over 7. And for A, because it is fixed, it is 0. So let's now have the fixed moment. So for BA, it is 27. So this is negative 10.205, 21.224. So for CD, negative W, negative 30, L square over 30. So again, negative W, L square over 30, so negative 36. Negative 30 times 6 square over 30 is negative 36. While for DC, the formula is positive W, L square over 20. So 30 times 6 square over 20 is positive 54. For DE, negative WL square over 12. So negative 27, 8 square over 12, negative 144. By symmetry, moment ED, fixed moment ED is positive 144. Then let's distribute. So quantity 27 minus 10.205 times negative 1 is, put it here, negative 16.795. Take note that this is already balanced. Then at C, quantity 21.224 minus 36, close, times negative 9 over 23, positive 5.782. Then times negative 14 over 23, put it here, 8.994. Quantity 54 minus 144 times negative 4 over 7, put it here, positive 51.429 times negative 3 over 7, replace negative 4 by negative 3 in your calculator, 38.571, and of course 144 times 0 is 0. Then carry over, so take note that this is already balanced, so let's lock B finally. Final moment here is 27 and here negative 27. Then we don't need to carry over half of 5.782 anymore because this is already balanced. So negative 16.795, put it here, times 0.5 or 1 half. Negative 8.398, 1 half of 51.429 is 25.714. 1 half of 8.944, 4.9497. 1 half of 0, 0. 1 half of 13.571, 19.286. Then distribute. So in this joint, quantity negative 8.398 plus 25.714 times negative 9 over 23 is negative 6.776. Replace negative 9 by negative 14, so negative 10.54. So 4.497 times negative 4 over 7, negative 2.570. Replace negative 4 by negative 3, put the value here, negative 1.927, and this is 0. Carry over, so none in this column. Half of negative 2.57, negative 1.285, half of negative 10.84, negative 5.27, half of 0, 0, half negative 1.927, put it here, negative 0.9635. Then distribute, negative 1.285 times negative 9 over 23, put the value here, 0.5028. Replace negative 9 by negative 14, put the value here, 0.7822. Negative 5.270 times negative 4 over 7, put the value here, 3.011. Replace negative 4 by negative 3, put the value here, 2.259, then 0. Carry over, so again here none. 3.011 over 2 is 1.506, 0.7822 times 0.5, 0.3911. Then half of 0, 0, half of 2.259, 1.130. Then distribute. 1.506 times negative 9 over 23, put the value here, negative 0.5893. Replace negative 9 by negative 14, put the value here, negative 0.9167. 0.3911 times negative 4 over 7, negative 0.2235. Replace negative 4 by negative 3, put the value here, negative 0.167, then 0. Carry over, so none here. Half of negative 0.2235 is negative 0.1118. Half of negative 0.9167 is negative 0.4584. half of 0 is 0, half of negative 0.1676, negative 0.0838. Then distribute negative 0.1118 times negative 9 over 23, put the value here, 0.04375. Replace negative 9 by negative 14, put the value here, 0.606805. Negative 0.4584 times negative 4 over 7, negative 0.2619. Replace negative 4 by negative 3, 0.1965, then 0. Carry over, so none. Half of 0.2619, put the value here, 0.131, half of 0.06805, 0.03402, half of 0, 0, half of 0.1965, put the value there, 0.09825. Distribute 0.131 times negative 9 over 23, negative 0.05126, replace negative 9 by negative 14, put the value here, negative 0.07974, 0.03402 times negative 4 over 7, negative 0.01944, replace negative 4 by negative 3, negative 0.01458, then 0. So let's continue until the values are small. We end up at distribute to have same values left and right. So carry over none. Half of negative 0.01944 is negative 0.00972. Half of negative 0.07974 is negative 0.03987. Half of 0 is 0. Half of negative 0.01458 is negative 0.00729. And final, negative 0.00972 times negative 9 over 23, 0.003803. Replace negative 9 by negative 14, put the value here, 0.005917. Negative 0.03987 times negative 4 over 7, put the value here, 0.02278. Replace negative 4 by negative 3 over 7, put the value here, 0.01709, and 0. So let's now lock finally. These are smaller moments, though at joint D, the values are still 0.0. You can continue if you want, but consider this negligible. So let's end up by adding. So we have 27 here, negative 27. So adding the values in this column will add up to 11.742, while in this column it's negative 11.742. Adding the values in this column, we have 105.066. So in this column, negative 105.066. In this column, the value is 163.46. Therefore, the moment at B is negative 11.742. It was negative 11.738 or 738. So there's a very small discrepancy because this is by approximate method. So if you continue up to here, maybe one round, then they might be the same in three-moment equation results. But this value is similar to three-moment equation. This one is a little bit close. So therefore, MC is negative 11.742 kilonewton meter. M sub D is negative 105.066. And moment at E is the negative of this value. So negative 163.46 kilonewton meter. So that's it for this problem. I hope that you were able to follow and understood the tabulation and solutions.